It hasn't been the first one, but this is a new one. It's been going on for, a few months already, and we've learned a lot. So today I've decided to share our experience on the UTSC, so University of Toronto Scarborough Passive House Student Residence. Before I dive in, Monty talked a little bit about RDH, just summarizing what we do. Sorry, the slides are not cooperating. Okay, how's that? Yeah, that works. Okay. So a little bit about RDH Building Science. We do quite a lot of things. You can see we have, our core is back to building enclosure, but we added energy and sustainability. We have a really fun lab in Waterloo doing research and forensic for most of the time. And then a lot of repair, renewal and rehabilitation as well. So we have, as passive house people, which don't really fit into a proper department, we have the opportunity to always sit between the new building team, the existing building team, and the research team, always listening to all the mistakes and lesson learned that we have on our projects and trying to make the next project always better. So this is pretty cool to have all these people to rely on to make sure that we always do better time after time. And yes, we do a lot of passive house, as Monty mentioned. This is the University of Victoria on the left with Perkins and Will, the Nelson Tower in Vancouver with IBI. So we do a lot of this. We work with PHI, with VS, with Living Building Challenge, with CHGBC Net Zero. And yeah, we have a few certifiers, Monty and myself, on the staff as well. So it's nice to be able to see both sides and again keep learning from all the projects that are going through currently in Canada. So exciting all around. Okay, diving into the project. So here is where we're starting. So this is the University of Toronto Scarborough campus, and the rectangle is our project. So you can see there's a lot of work to do. We're currently looking at a parking lot alongside two of the main roads defining the campus. So that will be the first residential building out there, actually. So pretty cool. And giving you a little bit of a program before diving in. So this is a 9-story building. We have a small basement with a few amenities. Then the level 1 is completely defined as a communal space. And the main key in there is the kitchen and servery area. We get a bit of a transition space at level 2 with some residential and some communal spaces such as, student lounges and like spaces where there can be a lot of interaction. And then level 3 till level 9, we're completely splitting into the residential part, which works in different communities. If you can see my mouse here, you can see the 3 different wings. So, east and west, and the central one, which clearly defines communities within the student housing, giving a bit of a better sense of community in that building. One final thing as well before diving into the detail, we are working with a pretty fun or unusual procurement method where we had a compliance team taking the design to 100% DD. So that's a lot of details already, as you all know with Passive House. And shout out to the compliance team led by Handel and Core Architects with Integral, Stephen Winter, RWDI, and Jablonski on the compliance team. But this team had to hand over the design to a contractor team, to a design build team, which is led by Pomelo, a contractor from Quebec. And our role on this project is to be the passive house and building enclosure consultants to that design and build team. And we get to work alongside IBI again, MCW for mechanical, and EXP for structural. So you can see a lot of cool people to work with, but there's enough of that project to work on. So don't worry, it's all good. Okay, so with that bit of introduction, let's dive into the details. So how do we detail a large project, and how do we make it go across the finish line smoothly? We were handed a pretty cool package at 100% DD. we're talking about R30 till R40 walls, you know, yeah, above grade enclosure. So we're talking about certified windows, certified curtain walls, certified ERVs. We're talking about a box distribution system on the domestic hot water, making it very efficient. And we're also talking about a state-of-the-art kitchen with heat recovery in its ventilation system. So if you ask me from far away, I'm like, I don't think it can get much better from, you know, much better than that. However, diving slowly into all the details, we started to realize that this is definitely a good starting point, but the design doesn't finish just there. We found a lot of little things, and that's what I'm going to dive in right now. Starting with the below grade, which is literally what is happening or what will be happening on site really, really soon. We are always asking for that continuous layer of insulation to be everywhere. But when we start digging in and seeing what is exactly happening in our basement, you can see that, for example, the elevator pits start being a bit difficult because we have the wrong ground conditions, which means that we can't wrap at least the sides of the elevator pits here all the way further down to mitigate the thermal bridge. So not perfect, not quite optimal. So we're like, okay, we'll take that small hit there. Then we started realizing, oh, we also have a few sump pits hidden here and there. Let me dig them in to see exactly where they are. And they started adding up one after the other until we finally caught them all. You know, blew everybody's mind to ask for a fully insulated and airtight sump pit, which has never been done before, at least not, you know, with this contractor team. And then same thing again with the below grade detailing, right? We're starting to look at every single perimeter detail, right? That below ground to above ground detail is fairly critical, where we need that insulation all around. And then similarly with the structure that is within the footprint of the building, where again, we're gonna start insulating. Anecdote aside, I had another team meeting today, and again, we get asked, are you sure this insulation makes a difference? And time again, we're like, yeah, trust me, I've played with the model, I know what I'm doing, we really got to do this. But it's okay, I'm glad that we're discussing about this and agreeing that that's the right thing to do. So that's a below grade detailing. You can see that we were supposed to have a continuous layer of insulation, and then it turns a little bit into Swiss cheese between the structure and other things. So taking a bit of a hit single time, which is not optimal. Now, moving on to the exact opposite. If you start looking at the roof, the same thing happens again. We want that perfect continuous insulation layer, right? High performance buildings have to be like onions, right? You need all these layers of continuous tightness, insulation, all of them not interacting with each other. And yet this is what we got to work with. Roof anchors, we didn't think too much about them to start with. And then with a building this size, we started counting them all the way till 140. So this is 140 connection points with the roof anchors, which weren't greatly detailed to start with. You can see this is a bit of a significant thermal bridge, turned to you know, a better detail with IBI. Same thing again, still damage support. You know, all these pieces that are supporting all the HVAC kit on the roof, they started adding another 45 connection points. And then the windscreen attachment, same thing again, we have a terrace on which people need to be, you know, safely on, plus 31. Then ERV duct penetration, right? Every time we get, the ERV ductwork going through the roof, we're actually having small concrete roof curves that are hanging up. And then I'm not even discussing about the solvent pipes that go through the roof as well, the rainwater leaders as well. So it starts being a bit demanding in that continuity and insulation. For sure, you're maintaining most of it, but that small derating will have an impact firmly, and it keeps adding up. But what is key to remember is that at the end of the day, the best design doesn't matter if it doesn't get implemented, right? Like our job here is not only to design perfectly, but to get these buildings out of the ground and not keep on locking carbon. So when you think about insulation, that detailing around air tightness, the waterproofing membrane as well, that has to go all the way above all these firmly broken pads and all around all the anchors, we are asking, like, this is a tough job for the guys to do that on site. So this is not perfect. We're working hard to find alternative solutions that are completely thermal bridge free and sit on top of a roof insulation, but between different code issues and different, other constraints on the project, we don't always get to do this. So work in progress, hopefully we get to minimize this as far as we can. Finally, other things that, again, I'm not gonna dive into the details, but it keeps adding up, the solvent pipes, right? It's not supposed to be much, but on a building this size, when you start counting all the meters of drainage pipes, they can add up to a few, kilometers or so. Roof rainwater pipes as well. We're not having a super good drainage system on that side, so we are taking quite a big hit with all these ventilated pipes going through our building. Shading support to be firmly broken, curtain wall glass carriers, which can be easily forgotten, but again, with a very, more heavily glazed and open to the outside level 1, it starts adding up. Gas risers for feeding into the generator, all these little things are really starting to add up on top of the key thermal bridgings that were definitely well detailed from the outstart, right? Ground perimeter, intermediate floors, parapets. So all in all, if I look at this project, I think off the top of my head, the thermal bridging, due to all the things that I've just mentioned, they're adding close to 2.2, 2.3, I think, kilowatt hour per square meter per year. So this is not nothing. It's a fairly significant chunk of your entire, space heating demand budget that gets into there. So this is the size around the detailing. Now, as Monty mentioned, we're going to be the ones supporting Pomelo while being on site, getting that thing built. There's an interesting aspect about around procurement as well. Procurement. Okay, so first thing first. That might make a lot of people laugh, but time and time again, this keeps happening. And this is not because I'm French. It's, that whole way to describe what we're after between the passive house person and the rest of the design team, be it the architect, the mechanical engineer, the contractor, the trades, absolutely everybody. There needs to be a clear understanding of what we're after, just to be able to maintain that performance from A till Z, right? Like, this is absolutely crucial to get us through the finish line with the level of performance that we were expecting. So one thing I want to highlight here is, of course, there's a huge communication effort to happen with the design team. And I have to say, again, we're being very lucky to work with this team. Most of them have done passive house before. It is a smooth ride. But for Pomelo, for the contractor, this is their first time. And what is really important is for them to understand, and for the sub-trades to understand, what to have a clear understanding of what matters. And by that, I don't mean the exact product, because passive house is not tied to exact product per se, but to translate what are the performance targets hidden behind the detailing or the products that are being specified, so that when they come in with product substitutions or alternative ways to build, they can come in with an informed design to the table and help us do this thing better. So I don't have enough time to touch on everything. I decided to share a little bit on Windows today, which was a fun ride. First thing first, language. Well, it all starts with NFRC versus ISO, right? Passive house works back with the ISO standards. NFRC works with slightly different standards, which are based in North America. So it's important to set, you know, the basis of design, what we're working with. So on this note, I'm going to do a quick plug for the Peel, Passive House, and RDH paper that has done a full protocol paper helping everybody in the industry, manufacturers, to translate between one language to the other so that you can please everybody. That makes me a happy girl when I get that. So that was the first thing, which already took a little while. Then we have passive house frames, right? For both the punch windows as well as the curtain wall. So you'd think it'd be easy from there. Well, what I found is I was spoiled when I was practicing in Europe, because when you ask for a frame and you go onto the Passive House website, the certified product database, you get told you're gonna have that frame and that's gonna be your spacer and you're all taken care of. You know, you can relax. However, in North America, it seems that the spacer doesn't make it through, you know, across the ocean. So every single time I've had certified frames, I've actually had to have a separate conversation with the manufacturer to say, hang on, I have this on the certificate, but what are you actually getting me? You know, what are you delivering on this project? So again, it's not undoable, but it needs a bit of extra work and being aware of this from day one, not to be get caught at the last minute. This has happened on other projects, UVic and UBCO and other student residents we're working on as well. And that puts us in a difficult position when these changes are last minute, because obviously the margin that we get into the model disappears with time. Bird-friendly glass as well. I thought I had a great, you know, great glass spec. I was like, easy. And then we realized that for the Toronto Green Standard, we have to work with bird-friendly glass. Totally okay, the right thing to do. However, my 0.55, you know, watt per square meter per Kelvin center of glass U value got very easily transferred to a 0.88 on the first quote, where I was like, we're not going to be friends. You might want to take your pencil and try this thing again. And after a bit of discussion, bouncing ideas everywhere to trying to sort it out, we managed to find a clever way. As you can see just on the drawing explaining what this is related to, is that you do need that pattern for the birds on surface number one, which is the external surface, but that has a domino effect on where you can put the lowy coatings that are getting you that great center of glass U value. So that knock-on effect of adding the freak pattern at the beginning led me to, you know, spaces where places I didn't want to go to before going back to 0.556 watt per square meter per Kelvin. Okay, I can live with that. Let me work on my model. Large sizes as well. At an early stages, we don't necessarily talk directly with the manufacturer to say, okay, tell me what is the biggest operable window I can have before we start needing extra support. So same thing again, we got the certified frame. I was all happy. I reviewed the first submittal, and half of my frames had, you know, a terrible frame thermal performance. And I asked a few more questions, and I'm like, oh yeah, there's still in there. We can't give it to you that big without this. So again, with a bit of massaging, a bit of work around, we actually didn't have to change the design, but that was a bit of a work process for them, with the manufacturers to get back to a minimal amount of frames needing that still support, which moves the frame performance from 0.76 to 1 watt per square meter per Kelvin. And finally, I mentioned them before, curtain wall. It's not much, but that little point thermal bridge times 2 per panel times the number of panel on these large buildings add up to quite a bit, especially if they might not be thermally broken or, sorry, non-conductive glass carriers. So you might want to keep that in mind. So in summary, when we're detailing large buildings, you already know the key formula, right? You already know the starting point. We need a great enclosure and we need a performing HVAC system to back it up. However, I would urge anybody working on a slightly bigger project to keep an eye from the very beginning, maybe not on a detailed design, but on the strategies that are being used for all of these small items that start adding up fairly significantly on this project. And secondly, if we look at the procurement, it's absolutely key to be able to extract in a language that everybody can understand these performance targets for the contractor and all the trades working there, so that that communication is, channels are wide open. And then that attention to detail that I cannot emphasize enough, because, we got to start delivering what is on drawings, not just, that's how we did it for the last 30 years, right? So that attention to detail is absolutely critical to get us through the finish line. There you go. That's what I've got for you tonight.